Write down. Chapter 10, Wave Optics, which is also called as Physical Optics. Okay. So like how we saw in the previous chapter, ray optics was also called as geometric optics. In a similar way, when you talk about wave optics, it is also called as physical optics. Okay. So basically, optics is a branch of physics which deals with light. So optics is a branch of physics which deals with light. Optics is further subclassified into two types. One is called as ray optics and the second is called as wave optics. Right. So knowing this fact, we will try to answer. This is when light is interacting with objects whose size is comparable to the wavelength of light used. Means if light is interacting with those objects where you can compare the wavelength of that light with the size of the object, under that scenario, the branch of optics that is classified is ray optics. Similarly, when you talk about wave optics, it is a place where light is interacting with objects whose size is small compared to wavelength of light used. Means if the light is going to interact with very small obstacles like small openings where those opening size is going to be very much small compared to that of the wavelength of the light that you're going to use, under that scenario, the branch of physics that comes into picture is wave optics. Please make a note of this point. Now, I am going to explain you a small story of why this wave nature of light actually came into existence. Okay, there were certain theories which were proposed in the early stage itself, but since they didn't have proofs at that point of time, they couldn't prove it at that point, hence it took some time for that proofs to come out. Now listen to this. So first there is something called as corpuscular theory of light. So basically corpuscles are nothing but particles. So initially what happened, it was assumed that light did not have any wave properties and people thought it had only particle nature, and this was the theory which was first proposed by Newton. So what happened at that point of time is when Newton proposed it, he was a very big scientist where people started believing him. There was no counter for his statement. Okay, they started believing yes, it had particle nature. But there came an other scientist named as Huygens. Okay, Huygens, or some people call him as Huygens. So what he told is light did not possess particle nature, rather it had wave nature associated with it. Now the concept is, where did he get this idea from? That is, listen to this. Suppose there is a small opening and there is a wall. Okay, let's say this is the opening of a room and this is a wall. Now if light rays are falling on this, right, if light rays are falling on this, had light been of particle nature, then what should have happened to all these particles? They would have gone and they will fall on the wall, means only this part of the wall would have been visible. But the important point that we need to notice, suppose you have a room where you have a window. Let's say this opening is a window. when light is going to enter through it, it is not only the wall which is, so on the wall which is opposite to the window, it is not only the area where the window is present is visible, but what will happen, you can see that even small parts above and below the size of the window will also be visible, where this is a phenomenon. So this phenomenon is called as diffraction. Generally what happens is, suppose let's say the door is closed and you're in this room and there is a person standing here and shouting. Okay, so if suppose they are shouting, what will happen is, when you're here, you might be or might not be able to hear them. But if I create a small opening like this, means let's say the door is slightly pushed like this so that there is a very small opening that is happening, then what will happen, the sound will travel through this and it will come and fall into your ears. Definitely compared to the previous scenario, in this scenario you're going to have a more intense voice that is reaching your ears. So from this we can conclude that sound is undergoing something called as diffraction. Diffraction is nothing but something similar to refraction only, but diffraction or diffraction, however you want to pronounce. It means that the wave will start bending when it hits an obstacle. Okay, so wave is going to start bending when it hits an obstacle, and this was the principle that was observed by Huygens, and he proposed the wave nature of light. But at that point of time, what happened is people were not ready to believe, because Newton was a big hand at that instant. Okay, it was later where certain experiments like Young's double slit experiment, then photoelectric effect. So all these experiments came into existence to prove that light had wave nature here and also it had particle nature here. So here what I did is I explained both the points. So the conclusion that I want to draw here is, light does not have only wave nature. So wave nature of light was proven by a scientist named Thomas Young through an experiment called as YDSC, Young's double slit experiment. And photoelectric effect was the one which concluded that light had particle nature also. So this is the reason why we say light has dual nature associated with it, and that is the main objective of next chapter. Anyways, in this chapter we are going to concentrate only on wave nature of light.